Welcome to the Explainer. Today, we're going to dive into a mathematical tool that's, believe it or not, helping scientists solve some pretty huge real-world mysteries, and even save endangered species. This is bigger than homework kits about using math to actually understand and protect life.
Absolutely. To keep it clear and inspiring, we'll trade off by topics. Each of us takes one key idea, and we'll pass the baton with questions and reflections so the story flows. I'll start with the core challenge scientists face every day, then hand it to you for the how. Let's kick things off with a big one. Biologists and ecologists constantly ask, how do you take all that messy field data, population counts, health stats, all of it, and actually predict what's going to happen? The answer isn't more binoculars or just bigger computers. It's a surprisingly elegant tool many of you are already learning. It's about finding the hidden pattern inside the chaos. Before scientists can make sense of anything, they have to face a flood of raw data. Imagine you're a marine biologist tracking two competing shark species. Your notes might look like a cluttered table, a jumble of numbers, changing month after month. The information is crucial, but it's messy and hard to work with as is. Here's where it gets exciting. We can bring order to that chaos by organizing the exact same data into what's called a matrix. Look at the right, clean, organized, and ready for powerful math. That's a matrix, numbers arranged in rows and columns, like a super-powered spreadsheet built for real calculations. It's the key to unlocking the story hidden in the data.
Love that. If you've ever stared at a messy spreadsheet and felt overwhelmed, this is your turning point. Organize, then analyze. Let me show how simple operations give big answers once your data is in a matrix. With our data neat and tidy, start with a confidence-building question. What was the total shark population each month? Now it's incredibly simple. Add the species counts month by month, month 1 plus month 1, month 2 plus month 2. The result is a new list showing total population over time. Simple, clean, powerful.
Exactly, and students, that's your first win. Tame the chaos, and simple tools suddenly become powerful. Ready to level up? Here's a real conservation question where one clean operation makes a critical difference. Researchers studying Hawaiian green sea turtles need the total number of eggs being laid. They have two groups, novice turtles and mature ones, and each group lays a different number of eggs. How do we combine that information? We use the dot product. Pair the matching numbers, multiply each pair, then add those products. One operation, one crucial number, nearly 750,000 eggs. That's not abstract, it's a vital statistic for conservation decisions.
That's the mindset. One clean operation, one meaningful decision. Now for the moment where this really takes off, scaling from one number to a whole snapshot at once. The dot product is great, but the real magic shows up when we multiply entire matrices. Think back to our sharks. Scientists don't just count, they track health indicators: average weight, percent wounded, percent with lesions across time. How do you compute all of that together? Start with the population matrix, 6 months by 2 species. Build a second matrix of indicators for each species, say, average weight, wounded rate, lesion rate. Then multiply them. In one calculation you get a complete health snapshot across all 6 months for all 3 indicators. What used to take dozens of separate calculations now happens at once. That's the power of matrix multiplication. And a quick but important idea that shows up everywhere: scaling a whole vector by a rate, say taking the species counts and applying 0.25 to represent a 25% wounded rate, is scalar multiplication. One number stretching or shrinking an entire vector. It's simple, and it plugs right into these larger calculations. Stack the monthly lesion totals into a single vector v, and you've just built a clean linear system, sxy to the power of t equals v, where s holds the species by month counts and xy to the power of t are the unknown per species lesion rates. That's modeling. That's solvable. That's how numbers turn into knowledge.
And this toolset isn't just for counting animals or calculating weights. It's used to understand the building blocks of life itself. By organizing data this way, scientists can literally see and calculate the invisible connections that shape the world around us. Matrices help track how traits like blood types pass from parents to children. They help ecologists map food webs to test ecosystem stability. And they can even measure how genetically similar different species are. Look at this, a matrix of genetic distances among 4 animals. The smaller the number, the closer the relationship. Even without being a geneticist, you can read the story. The distance between a human and a rabbit is tiny 0.028, while the distance to a frog is much larger. It's a visual map of evolution, laid out in a simple grid. How cool is that?
Here's the big idea to carry with you. This isn't about crunching numbers for the sake of it. It's a framework for understanding. It's like a language that can describe complex patterns of our world in a simple, elegant way. The next time you see a matrix in your homework, don't see a boring block of numbers. See a key that organizes chaos, reveals hidden patterns, and unlocks solutions to problems that matter.
So start small. Take one messy table in your next project, turn it into a matrix, and ask one clear question. Publish a tiny insight no one saw before. Then another. And another. What do you think? Ready to use this key to make something real?